I'd like to take some time in this video to go over the differences between a single equal sign in computer programming and double equal signs in computer programming. We have previously seen a single equal sign, and we have been reading that in a computer science setting as an assignment operator. So we have previously seen syntax of the form double hourly rate is assigned a value of $15.75. And that single equal sign again is read as is assigned a value of. So the use for this single equal sign is when we are either initially placing or changing the value of a variable. Later on in our program, and particularly as we dive into branching and flow of control, it's often the case that we want to take a specific action based on the value that is within a variable. And remember that because many of our variables may be entered by a user, we may not know as programmers what is stored within that variable. So we often have to ask a question and ask, is the value that's contained within this variable equal to something or not? If we have a particular variable and we want to check if its value is equal to something very specific, then we need to use a different symbol since we are performing a different action. And the way this manifests in computer science is that when we are checking the value of a variable, we use two equal signs instead of a single equal sign to denote that we do not wish to assign a value to that variable, but rather we'd like to check for what's being stored inside that contents. The difference being, are we just opening up the locker and looking at what's inside, or are we opening up the locker and putting a new thing inside of it? Now, this is a very sticky point. It's a very easy thing to be confused on, and it's a very easy typo to make. Therefore, you should expect at least once in your life, if not several times in your life, to make a mistake where you mean to check the contents of a variable, which would be done via these two equal signs, and instead you accidentally type just a single equal sign here. That mistake will be made frequently due to its nature, and it will create a problem in your program where instead of checking the contents of hourly rate, you assign a new value to the contents of hourly rate. Don't fret if you make this mistake, just know that it's possible and it can lead to some real moments of wanting to rip your hair out. Know that everybody makes that mistake. Just make sure you do actually know that a single equal sign and double equal signs have totally different uses in computer programming, and we should do everything we can to try to avoid making that mistake. Now, one more thing to cover at this point, that integral to branching is the either implicit or explicit use of a different data type in C++ known as the Boolean data type. The allowable values for Boolean variables are only two things, true and false. There are also three operations that we can perform on these variables. The operation not, which is denoted with an exclamation point, the operation and, which is denoted with two ampersand signs, and the operation or, denoted with two vertical lines or pipes. If we wish to explicitly create a Boolean variable, the syntax for declaring and assigning values to Boolean variables is exactly the same as we've seen for previous data types. We declare the data type, create a space, and then name our variable. And then if we wish to, in one line, assign an initial value, we would follow the variable name with a space, use that single equal sign, which means is assigned a value of, and our initial value would go on the right of that assignment operator, followed by our semicolon. While we do sometimes explicitly create Boolean variables, perhaps more commonly what is happening in the background is that there is an expression inside of our branching statements that is evaluating to a Boolean, that is either true or false. And so it's important for us to know about this data type and what's going on in the background. Let's take a look at an example. In this example, we're considering a program that acts as something of a bartender, where we're imagining that we work at an establishment where there's a particular drink, and that particular drink has a cost. And known to us working in the restaurant is the cost of that drink. And so what's happening in line 8 is we've declared a double variable named drink cost and assigned it a value of $4.75. We then introduce two double variables for which we don't know the values yet, patron age and patron money. And these variables are meant to represent how old the patron is and how much money they have. Our criteria as bartenders is going to be if the patron is of a legal drinking age and the patron has enough money to pay for the drink, then they are allowed to have the drink. Otherwise, we'd like to print to the user that they cannot have this drink for one of a variety of reasons. Lines 11 through 14 describe that process of prompting the user to enter their age in line 11, storing what is entered by the user in the patron age variable in line 12, and then repeating this process for the patron's money. Line 13 prompts the patron to tell us how much money they have, while line 14 inputs their answer and stores it in the variable patron money. In order to demonstrate both branching and the Boolean variable, line 16 declares a Boolean variable called can have drink, but it does not assign an initial value to this variable. What lines 17 through 24 wish to accomplish is the check we discussed previously in English, whether or not the patron is of legal drinking age and whether or not the patron has enough money. So the check on line 17 first checks if the patron's age is greater than or equal to 21. So the first part of the check on line 17 is whether or not the patron is old enough to have an alcoholic beverage. We then use this Boolean operator, two ampersand symbols, to say that is insufficient. It is necessary for the patron to be at least 21 years of age, but it is also necessary for the patron to have enough money. So what comes on the right-hand side of the two ampersand signs is a check for whether or not the amount of money entered by the patron, which is the amount of money they have, is at least the cost of a single drink. In the event that both of these criteria evaluate to true, we will assign a value to the can have drink Boolean variable of true. If either of these two conditions fails, either the patron is less than 21 years old or the patron has less than $4.75, in either situation we will say the patron cannot have a drink for one reason or another, and we'll assign a value of false to the can have drink variable. While the declaration of the can have drink Boolean variable on line 16 is an explicit creation of a Boolean variable, it's important to note that there are two Boolean variables on line 17 as well. This patron age greater than or equal to 21 is a check to say, is the patron age greater than or equal to 21? If that is true, then this becomes the Boolean word true. The other check on the other side of the ampersand, where we check to see if patron money is greater than or equal to drink cost, is also giving us a value of true or false. And so the value on the right-hand side of these two ampersands is also a Boolean value. We actually have three different Boolean values occurring in this program. The one created explicitly on line 16 assigned a value either in line 19 or line 23. A Boolean value right here on the left-hand side of the ampersand in line 17, and a Boolean value right here on the right-hand side of the ampersand in line 17.